Welcome to Rookie Aspirant. Perform a quick calculation in your head while someone is watching, and you likely feel a familiar friction. For most of us, mental math on the spot creates immediate psychological pressure. Take 32 times 64. Our brains default to the traditional stacking method, working right to left. This relies on holding carried digits in your mind. Without paper, short-term memory fails, and the calculation collapses. Bypass this bottleneck by reversing the direction of the math. By working from left to right, you break large numbers down by their actual place value. Changing the physical direction of the process shifts the mental load. This approach converts a multi-digit multiplication into a series of simple addition steps. We can master this left-to-right framework by starting with a simpler equation, 21 times 7. First, isolate the tens place of the larger number. Multiply that 7 by the 2, which gives us 14. Since that 2 represents the tens place, we apply the zero drop rule. We add a 0 to our result, turning 14 into 140. Now we multiply the ones place. 7 times 1 is 7. Add that to our 140, and we have our final answer, 147. This rule remains consistent regardless of the digits. For 17 times 8, we do 8 times 10 to get 80, then 8 times 7 to get 56. 80 plus 56 gives us 136. The left-to-right framework neutralizes the need to hold numbers in your head. You are simply performing a two-step addition sequence. This place value rule scales up easily to equations where both numbers have two digits, as long as you know one of the multiplication tables involved. Take 21 times 14. We multiply the full 14 by the tens digit, the 2, to get 28. Dropping the 0 makes it 280. Next, we multiply 14 by the ones digit. 14 times 1 is 14. Add that to the 280, and we get 294. Increasing the scale of the numbers leaves the underlying mechanics of the place value breakdown completely unchanged. We can now return to that intimidating problem, 32 times 64. In this case, we'll assume neither of these multiplication tables is familiar. We can solve this by factoring. We break 64 down into two smaller, recognizable factors, 8 times 8. Now we apply the left-to-right method to the first factor, 32 times 8. That's 240 plus 16, which equals 256. We take that new total and run the process one more time against the remaining factor of 8. We process 256 times 8 in 3 parts. 8 times 200 is 1600. 8 times 50 is 400, and 8 times 6 is 48. Finally, we sum the 3 parts, 1600 plus 400 plus 48. This gives us a mathematically accurate total of 2048. Combining the factoring tactic with the place value method allows you to defeat even the most complex multi-digit equations. Compare how you feel about mental math now to how you felt 5 minutes ago. You just navigated a multi-level calculation without using a single scrap of paper. You now have your first key tool, using place values to eliminate the strain on your short-term memory. You also have a secondary tool, factoring. This serves as an emergency bypass when you encounter multiplication tables you haven't memorized. Take these modular tools and look for opportunities to practice them in your daily life. Cognitive efficiency in math comes down to the smart, modular organization of data rather than sheer computational brainpower.